Alright guys, today we're going to be looking at Cantor's missing number theorem. And Cantor's missing number theorem, he did this proof using diagonalization. So we're going to continue using diagonalization, and we're going to start asking ourselves one very important question. It may seem more intuitive, but of course, being mathematicians, we have to have a proof. We can't just assume something. So we're going to look at one of his theorems using diagonalization, and we're going to ask ourselves, are there more natural numbers than real numbers? And again, like I said, this may seem more intuitive, but we can never just assume something. So for there to be more natural numbers than real numbers, that means that there is not a one-to-one correspondence. So they would have to have, again, a different cardinality. Okay, so let's look at a table here and see if we can find out that it does not have a one-to-one correspondence. Okay, so this table that I have right here, notice in the left-hand column we have natural numbers. In the middle column we have real numbers, and these are numbers between 0 and 1. And what we want to do is construct a number using only 3s and 7s that is not found in our list of real numbers, because what that would mean is then we have a real number that doesn't correspond to a natural number. Therefore, then there would be more real numbers than natural numbers. So the way we're going to do this is we're going to look at our real numbers here. And we're going to, again, using that diagonalization, so natural number 1, we're going to start with that first decimal place. That number is a 5 right here, and I'm going to go ahead and put a box around that, and that'll help us easily identify our diagonalization. If a number is not a 3, we're going to put a 3 in that spot. So since this is not a 3, I'm going to write 0.3. I'm going to move to the second number. So natural number 2 is going to correspond with my second decimal place. Again, it is not a 3, so I can put a 3 in that place. Notice that I just brought down the 3 in my first decimal place from the previous number that we use and what we're going to use to construct. Okay, natural number 3, third decimal place, that number is a 4. It is not a 3, so I can put 0.333. Natural number 4 corresponds with the fourth decimal place. This is a 2. Again, not a 3, so we're on a roll here with our 3s. We have 4 3s after our decimal. Natural number 5 in that fifth decimal place. This time we have a 3. So in the case when we have a 3, we're going to then implement or input a 7 into that decimal place, because we want to make sure, for sure, 100%, that this number that we're constructing is not found in this list of real numbers here. Okay, so we're going to have 0.337. Okay. Next decimal place is a 7, so again that is not a 3. So we're going to put a 3 in that spot, still bringing down those previous numbers. Next decimal place we're looking at is a 9, not a 3. So we're going to put a 3 in there. Natural number 8 corresponds with decimal place number 6. Okay, so 3, 3, 3, 7, 3, 3, 3. And our last number, we're looking at natural number 9 in the ninth decimal place. That is a 7. So again, not a 3. So we're going to put a 3 in that ninth decimal place. All right, now we have constructed a number n, and notice with what we've constructed, this number right here is not found in our list of real numbers. So what we have shown is that there is not a one-to-one correspondence between natural numbers and real numbers. So what we now can conclude, there are more real numbers, oops, there we go, real numbers, then natural numbers. And again, that seems pretty intuitive, but we have now shown that using Cantor's diagonalization method that he used.